Hello and welcome to another tutorial. So this time this is going to be one where we are going to be building up a character controller, initially a first-person character controller. So this is actually going to be spread across a couple of videos because it's something where it's very easy to get a few sort of key essential bits up and running, but then getting some sort of the more complicated areas where we're dealing with stuff like slopes and steps and handling those well, those can actually be quite a bit more involved. So the focus this time is going to be purely on getting movement, getting the camera going, not worrying too much about things like slope limits and stuff like that. So just getting some of those key essentials up and running for it. So in terms of what we've got set up, so you might have seen this in other projects. This is the testing environment I use for character controllers. We've got some steps, the idea being a character should be able to walk fully up those, and a whole bunch of slopes at different angles. So there's ones that essentially increments from 15 up to 75 degrees, and then we've obviously got vertical ones there, so it gives a few different options there for this. Now with this project I have brought in Cinemachine and I've brought in the new input system, so it's going to be making use of both of those. So first thing we need to get going is we need to actually create a character model. So what I'm going to do is 3D object, and I'm going to create a capsule. This is going to be our player. I'm going to bring this up. So in terms of height, the height here is something where that matters because that's obviously something we design our game around. Different games might need a different height. Our character controller should be able to handle multiple different heights. So in this case, I'm going to say that the character height, we're going to make it that it's 1.8. I'm not going to worry about the visual mesh there because that will be something that I do turn off. We don't actually need the mesh to be shown. So I've dropped the height to about 1.8. That's a fairly standard sort of height you'll see for a character. And then position them perfectly on the ground. And I'm going to give them a rigid body, because I want this to be a rigid body based character control. So, okay, so far so good. I need to give it a camera. So usually the player and the camera are separated, because if we think about it, when we're looking around, when we turn, it makes sense for the actual player to turn. So for that is going to rotate the character. But for pitch changes, a character doesn't look up and down by going like that or leaning far forward. Their head tilts, their eyes move. So that's why we want the camera to be separate so that we can then actually move it independently. So I'm going to create a Cinemachine virtual camera. And this is going to be player camera. So we just want to position that at initially 0. Now height-wise does matter. We want this to be at about sort of the eye height. So the character is, we've got them as being 1.8 meters high. So if we set this to 1, and this is one where if we turn on the visual mesh again, that'll make it a little bit easier to see where that camera is placed. So we actually want that a little bit below that. We're going to drop that to probably 0.15. Feels about right. It's going to be something that we would adjust based upon feel. But that's good. We've got our camera. So we've got the player, camera. We're going to tag them as a player. And the camera tag as player as well. So that's the base structure that we've got. Body will set it, and aim will set as do nothing because they're going to be fully controlled within the game. So as the player moves, those will be able to be moved. So okay, that's pretty good. That's our starting point in terms of structure. So with this I want to be using the new input system. So on the player itself, what I'm going to add in is, if I search for input, we have player input. So that's one that I want to have set up on this. We can link up a camera. So we've got that set up. We're going to set up stuff in terms of our input and things like that as well. In terms of the input module, we don't have anything we need to select there at the moment. That's okay. That would be in terms of if we had an input system, we can link up stuff there. I will create the actions though. So we'll create a default set of actions. And I'll create a new folder here called data. And we'll call this FP controller. So, first person controller, the default set of options we'll have stuff that will have move, we'll have look, and we will have fire. Going to change this to primary action, because I want to have support for primary and secondary actions. So that's the other thing I'm going to do, is duplicate this to secondary action. And that will allow me to then switch all of these over. This will go to left trigger gamepad. This will go to right button. Its naming there is not entirely accurate in that its right button there actually is going to use whatever you've configured as your secondary button. It's not always going to be the right one, so you don't need to do logic in your game for if there is switching in terms of the handedness for the mouse. For this, touch screen, there may not be a secondary input, which makes sense, so that I will get rid of. Now the joystick trigger, that's one where if we look under joystick, we don't really have an alternative option one there, so I'm going to get rid of that. And for the XR controller, they might be specific to just the particular ones there, the particular types of setups. So there may be the secondary touched. It might not have the particular one we're after, which is okay. It generally is one where at least we've got the stuff set up for these. We could add in different ones depending on a particular game later if we need to. But we've got those set up. Got move, look, primary, secondary. Also, would be kind of good to have jump. So let's add in jump. So with that, we want to have space is going to be one of the inputs. That'll be for keyboard and mouse. We can add in another binding. So if we go to the gamepad, try to remember what button would it normally. I have a feeling it would normally be something like the south button. Again, we could easily change that. That'll work for gamepad. So, okay, we've got those set up. So we've got our primary action, which is there as buttons. That's in terms of, we could also set up the keyboard input if we needed to as well for that. We've got our secondary actions. We've got the ability to look around. So that's input that we'll be able to have coming into our setup. So now we can start to set up some of the essential bits for our character controller. So I'm going to create a folder for some scripts. And so this is going to call this character motor. And I'm also going to split the config out into its own file. Now the reason I do this is I will make that config a scriptable object. The reason I like doing that is because, and I do this in particular with ones where I know there might be a lot of data setup. So the reason I do that is it means that the data is split out from the object, so I could have multiple different prefabs that link to the same config. I find that it works out a lot better in terms of being able to maintain and work with the code. So we'll set up that config first so that it's able to be created so we can have one of those assets. So our usual logic, that's a scriptable object. We are going to have that this is a create asset menu. So we have our menu name, character motor, config, item or file name, character motor config. Just means that it's easy for us to set this up. We can then be working with it on our different things quite easily. So then data-wise, I'm going to create that config, default fp config. Which means that I got it there from the start, makes it easier than trying to move things in later on. So in terms of then the character motor itself, well, we can start to pull out a few things that it's going to need. It's going to need to know the rigid body. So it's going to need the linked rigid body. It's going to need the camera. So we're going to have transform linked camera. It's going to need to link to the config. So serialize field, character, motor, config. So stuff like the rigid body and that, those are an essential thing. So that I'm going to make it that it forces that to have to be there. In awake, we'll do our retrieving of things as normal. Get component of the transform. So that's good. We've got our starting point. We've got those bits of input there. Good. So first things we want to do is we want to actually get our inputs coming in. Now, the event system, because we're using the new input system. So new input system data, there is a way we can use it in a polled mode, but I prefer to use it in its event-driven mode. So we're going to have events coming in. That gives us our input. But this is something that is rigid body based. So that means we want to be working with the changes in fixed update. So what we're going to need to do is we're going to, as we get inputs come in, we're going to cache those inputs, and then we're going to use them later on in fixed update. Or an update depending upon the nature of the data. So to work out what our inputs are going to be, conveniently, you can see we've got this here. This is telling us all of the messages that it will send. Now, we unfortunately can't just go and copy that, but it gives us a list of ones to be working from. So I can bring this over here. I'm going to bring in the Unity Engine input system. So bring in the new input system. Now this is a case where I would generally use a region for grouping the input handling stuff. So input system handling and region. So I can see what the functions are going to be called. So I'm going to have an on, and I'm not going to hook up all of them, but I'm going to hook up a couple of the key ones. So it'll be on move, and we'll see in a moment what we get context-wise for that. So we'll have on move. So I'm just going to run that, just because what I want to see is, do I get anything coming through already? That's what I initially want to see. Because we're not necessarily matching the appearance correctly, so we don't get anything coming through, and that's kind of to be expected. We have to actually provide the correct argument here for this. So these will typically be an input value, and then we can log that out. just so we know that stuff is coming through. So always really important to make sure that we check this stuff. Also, we'll find out if this then works. We're expecting to see output in the console. So we don't see anything yet. So the issue we're running into, really easy one to have happen. It helps if we link up the actual character motor script to the object so that it can run it. So we can just add that onto the player. Then when that's on the player, we can link up a particular config. And what we will find then is when we go to run this, we can move, we get input, which is great. So we've got movement input. We can see the name of what the other inputs are. So we can get each of those set up. So we've got move, and what we'll do is we'll cache each of these. So I'll have a vector 2, and we'll make this protected, and each of these actually I'm going to have them be protected rather than private, so that it's something where if we wanted to later on override it, we easily could. So I'll have our on move, so this is going to be input move. So then we can store these. So input move, we can say value get vector 2. So that's what our move looks like. We're going to have a couple of other ones. So we're going to have our look input. That will be on look. We also have then our button ones. So jump, fire, so primary, secondary action. So we will also have protected bool input jump. Same structure for these functions. So void on jump, input value, value. Then with this, we can say input jump is value. This is one where we can actually check, is that button considered pressed? We can then do similar stuff for primary and secondary actions. So we'll just have each of those. So input primary action, and then a similar one, input secondary action. So on primary action, and then on secondary action. All right, so that should give us enough input that we can start to do things like being able to look around. So first thing, as soon as we've got looking around happening, we want to have sensitivity options for that. So let's get a couple of our key camera settings up. So we want header, camera. So, well, first thing, invert Y. This case will default it to off, but always have an invert Y setting. It's ridiculously easy to add in, and it's something where there are, it's quite a large proportion of people that will play with inverted controls and find not being able to invert the controls makes the game, very difficult to play, potentially to the point of being unplayable or unpleasant to play. We don't want that. We want our games to be easy to play, we want them to be enjoyable to play. So let's make sure we've got inversion options in there. We want to have sensitivity options. So we want our horizontal and vertical sensitivity. So horizontal sensitivity, that let's go for, don't really have a good feel for what a good value is going to be initially. So we'll start with 10 and we can adjust it. And we'll have vertical sensitivity. We also want to be able to limit the pitch potentially, so the angle that it can tilt. So public float min. So actually we'll preface these with camera min pitch. So think make it that the most it can pitch down is maybe 75 degrees. And the most it can pitch up might be the same as well. So camera max pitch of 75. So just preface all of these like that. So that's good. Got our configurations there, so we can start to do the looking around. It's not uncommon for a camera look to happen in late update. So we'll do that. We will make this protected though. So I've got our input. So then with that input, I need to transform that. So, okay, well, I've got my input from the look. So X is going to control turning around. That's the one that will actually turn the character. So input look X, we need to multiply that by our config, and in particular, our config's horizontal sensitivity. So we'll have the config here. So it would be camera and the horizontal sensitivity. So that's going to give us the input in that regard. But we'll only be able to do a certain amount of change with time. So multiplied by time.delta time. So this is going to be float your camera, your delta. Then we need the pitch delta. So camera pitch delta. It's going to be quite similar. So input look.y multiplied, in this case by our vertical sensitivity, by delta time. Now this is one where we can factor in that inversion at this point as well, because what we do is we chuck in a little thing like this, where we do config, camera invert y. So if we are inverting it, then we generally keep it as 1, otherwise -1. So that looks good. So here we're calculating our camera inputs, and we're calculating those with respect to time, which is good, means it's going to be smooth. So then what we need to do is we need to do the rotation. So there's two separate things we rotate. There is the character for yaw, and there is the camera for pitch. So what we need to do for the character rotation, well, firstly, we are wanting to work in quaternions. So new char rotation. We take our current rotation, and in particular, we're going to take our local rotation. We then multiply that. So with quaternions, the way you add is by multiplying. The way you subtract is by dividing. So we do a quaternion Euler. We do 0, camera yaw delta, and 0. So we're only performing your actions on it. So that's good. Then we can actually set the new character rotation. So we can go, well, transform.local rotation, and we actually can just do it direct in line with this. If we're wanting to do any lerping, we could easily do that as well and have it in a separate one. So rotate character, pitch the camera, so we tilt the camera. So for the camera, we do a similar thing. Now the main difference with this is for us to be able to clamp it. Kind of what we need to do is we need to actually always keep track of the camera pitch. So we are going to have protected float current camera pitch is 0. Then we're going to be able to here say, well, current camera pitch plus equals our camera pitch delta. But we want to have our clamping. So what we can do is our camera pitch is a mathf.clamp of current camera pitch plus the delta. And then the min that we're clamping it from is camera min pitch to max pitch. So it just means that the input is always going to be within those ranges. I've tried a lot of different approaches for clamping camera pitch, stuff like that. This is the one that I've found that seems to work the most reliably, has the least artifacts. To then change the actual pitch, well, camera, which that we use linked camera, transform, and its local rotation is a quaternion dot Euler. We give it the current camera pitch and 0 for the others. So this should, as we move the mouse around, tilt the camera. Now we'll likely need to adjust the sensitivities. The sensitivities will almost certainly be not where we need them to be, but that's okay. We can run this, and as I look around, you can see it does. It is managing to move me though. So that is stuff that we are going to have to need to resolve. That can happen with just the effect of the rigid body there, with stuff being moved. What we're going to do to get a bit of a better sense of what's happening, so we'll connect this up. So we can see that it's gone and tilted. So if we take a look, we've updated those. We want to take a look and make sure that we have everything configured correctly. So our character motor, the linked camera, we actually need to properly link that up. We didn't. That one was one that should have been serialized field. What we were doing was we were actually pitching ourselves, which was why it was doing that. Hilarious, but also a good illustration of why we want to have the camera separated. So now when we run this, so I can pan left and right. I haven't linked up the camera, so I link the camera up, and then when I run it, as I look around, so this is not with inverted controls, so moving up works, looking left and right works, it clamps, but then I was able to fall over, so that's something where we're going to have a little bit of a look at that. We do want to also make it so that we are locking the cursor. Lock cursor, or set cursor lock, because this is a common thing that we need to be able to do. So what we generally will do with this, so cursor visible if it is not locked, and then cursor lock state. Well, we also then check if it's locked, then we set it to that. Otherwise, we set it to none typically, because then in start, we set cursor lock true. That'll avoid just the cursor moving around on us, which we want to avoid. We don't want it moving around like it was. So now I don't see the cursor. I can be tilting. So I'm not going to be able to move currently. You can see it is when we look right down. That's where it starts to then actually do the tilting over. So potentially what we're running into is the yaw values there going a little bit off. So we want to just take a little bit of a look if we watch what's happening with the player at that point in time. It seems to only happen when we tilt like of that. And it's only when we look down far enough. And we can see we do get little bits of rotation in X and Z. And that's actually stuff we generally don't want. And auto would normally do. So it actually frees all of the rotations, because we really don't want the rigid body ever rotating except by our own direct instructions. So that's good. It's looking around. That looks okay. We want to check that the inversion is working. So let's test inversion. And with the inversion, that is correctly working. The vertical controls are inverted, which is great. Okay, cool. So we've got the ability to be looking around. We've got that nicely set up. I will protected void update camera, just in case we do want to move the updating of the camera to somewhere else at any point. I'm going to make it self-contained. Do really want to always try and keep our functions so that they are not ridiculous in size. So, all right, that's good. We've got looking around. Let's get movement going. So header, movement. So float. We want walk speed. We might set to 10. We also want running. Run speed might be 15. And we want to, for the running, indicate whether running is a hold or a toggle. Usability wise, something that I would really strongly recommend is always have support for it being able to be a toggle. I generally would advocate for toggle as a default, but if you don't have toggle as a default, make it as something that is an option players can turn on. In particular for something that is keyboard based. Having to hold down an additional key there when running actually can be quite difficult in some cases. So for like of me, I have nerve damage in my left arm. So once where I have to hold down a run key, it's actually really painful and difficult in many cases. So try and avoid needing to always hold down a key for stuff like of running. So is run toggle. Going to default it to true. Now we don't have an input for running at the moment, but that is something that we will get an input setting going for that. So we'll have one here. Input run on run. The nice thing with grouping those in a region is can just collapse the stuff, make it a little bit easier for actually visualizing everything. So I can very easily into my actions add in stuff for then a run. So I'm going to duplicate the secondary action one there. So we will duplicate that, call that run. That will change it from being the left trigger to left shoulder. And with keyboard and mouse, we'll change that to shift. So we've just got those as extra inputs there as well. So then in terms of for moving this, well, movement, we very much want to make sure that that is happening in fixed update. So that's something where we're going to set up here a protected void fixed update. Now there's actually going to be a bunch of checks that we end up doing here. So not all of the ones that we'll add in at the moment. There'll be ones that we add in later when we add in stuff for slopes and jumping off of things in areas like of that. So this is going to be, we will just mark out where we will have these. Check if grounded is going to be a key thing. Well, one of the big things we also need to update is, are we currently running? Because that has a bit of logic behind it. We also want to probably have a toggle here of, can run. So let's look at the logic this needs to be able to be doing. So update running. We will have here a protected void update running. Well, first thing it needs to do is check if we actually can't run. If we can't run, there's very little that it needs to do. What I will set up is a public bool is running that we can only set internally. Because if the config says that we can't run, then That's pretty easy. Is running is equal to false, and we just exit. So it cannot run. So that's straightforward. Next check we want to do is there will eventually be grounded checks, things like of that. Otherwise, what we want to do is say, okay, well, f config, so is run a toggle? So if run is a toggle option, there'll be some logic we do. Otherwise, if run is not a toggle, then is running is based upon our input to say that we're running. That's the sole criteria for it. Otherwise, what we need to be doing is checking. So in this case, we want to look and see, okay, well, if we're already running, or what the actual input has sort of said. So, okay, if we are, because the input will be able to be released. So this is something where if we are running and we have this input, then we stop running. So we have to have received an input run to change our state either way. So I can actually rely on it being like of this. So actually, we can just set it to the not of itself. So it will only change on receiving a new input. So we hit run key to start running, then we hit run key to stop running. Set up our run toggle. This is going to move further up to the top here, because it's going to be something we want to be able to easily access. Then we could have our setup for what our current max speed would be. So current max speed. Well, if we are running, then we use config run speed. Otherwise, we use config walk speed. So we now know whether we're running, we know what our max speed is. That gives us a lot of the key information we need for actually doing the movement. So we can get our movement input. Now our movement input is going to be pretty straightforward because we've already got the setup in terms of we're reading it from the input system. So there's actually not anything extra we need to do with that. We can just immediately go straight to using it. So how this ends up working is the first thing we need to do is, and I'm going to set this up, so update movement, detected void, update movement. So just keeping things broken up so it's very clear the functions they're performing. So first thing I need to do is construct my movement vector. So my movement vector, now this is going to be very much tied to the movement input. So what I will use is I will say that it is transform.forward multiplied by my move input dot y plus transform dot right multiplied by my movement input dot x. This will allow me to strafe. I need to factor in my move speed. So this is where I can multiply by current max speed by time.delta time. Because, and I'll put this actually on another line, movement vector times equals that. So I need to factor in time delta time so I get the actual full amount that it can move. So calculate our movement input. Now we can't just go and modify the rigid body based upon this because we need to actually get a sense of the slope of the surface that we're running on. Because if we were on an angled surface and we just tried to move, say, directly out, which is what would happen, we would end up in the air. If we're trying to move up a surface, we'd be constantly trying to push into it, which is going to make it really problematic. So what we need to do is we need to actually do a raycast. And we need to check essentially looking down. So this is something that comes into essentially our grounded check. And the grounded check is a pretty essential one because it's already having to do a raycast. We just usually get it that we return the result from it. So I'll have a protected raycast hit. Update is grounded. And what this is going to do is we need to check a certain distance and stuff like that, which means it's going to need some character information. So that means we need the character height. Means we need the radius. We'll go for 0.3, often tends to work pretty well. So that's good. So, okay, we then need to be performing our raycast. We also want to know, we'd set up here a header rounded check, because there's going to be extra stuff we want to do in terms of having our layer mask, grounded layer mask. Set that by default to everything. Won't necessarily want it to be everything. The player, I would often put them in their own layer. So I'm going to actually add a layer with them, put them into that layer, because then the config, I don't want to check against transparent VFX, don't want to check against ignore raycast, UI, or player. So it reduces the number of ones we're checking against. It's going to avoid a whole bunch of weird artifacts we could very, very easily run into. So, okay, that's good. Rounded check buffer, because we want to be able to check a little bit extra. I'm going to say 0.5. So what we need to do is we need to perform our raycast. So first thing, we set up our raycast hit. We are going to, in this case, because we're dealing with something that is a large object, we're going to actually use a sphere cast. So we need a starting location. So we'll have a start pos, because that will put that in the center of the character. So that's going to be a location we need to calculate. So we'll have vector3 start pos is linked rigid body position. So we want to very specifically use rigid body positions here, because this is all running in physics side of things. We want to use the rigid body position. Plus vector3.up times by config height by 0.5. So half the character height, in other words. So that's our start position. We have our radius. Now we might want to allow a little bit of a buffer for the radius. So public float rounded check radius buffer. Don't want it to be much, want it to be fairly small. A little bit of a buffer there can be good just to keep things a little bit further away from objects. So radius plus the radius buffer. Then we need to give it the direction. So this is vector3 down. Then finally, we want to be telling it the distance that it's checking. So the ground check distance. So ground check distance is going to be config height plus config ground check buffer. Now we actually can just use height by 0.5. Don't need the full height there. That gives us our ground check distance. Then we can tell it the particular things we want to be looking at. So grounded layer mask, and we want to very specifically ignore those queries. So we've got most of our bits here. We forgot to add in our out hit result. We've got that. So that's good. So if it failed, we return null. That's straightforward. Otherwise, we will return the hit result. We can also update the thing of whether it is grounded or not. So we'll have public bool is grounded. We will default that to true. So in this case, is grounded becomes true. Otherwise, is grounded would be false. So that's good. We have to return a hit result regardless, so we can't actually return a null. That's okay. So that looks good. We can do this as an else. The other thing we may want is we may want to set up stuff at a later point for auto-parenting. So perform sphere cast, add auto-parenting here. That's for if you've got something where it's a moving character on a moving platform, having that auto-parenting can be a real lifesaver. So, okay, so far so good. We're updating the movement. In terms of then with this, we can reorganize this, that grounded check, stuff like that. I'm going to perform that check here, raycast hit result. Call this ground check result. And I will actually pass that to each of these because if we are not running, so if if we're not grounded, then is running is false, and we return. We might want to potentially do stuff with the ground check result here, changing surfaces, stuff like that. Could very easily do. But now that we've got this, that gives us information about the surface that we're moving on. Because what that allows us to then say is, okay, well, if we are grounded, then we take that vector and we project it along the surface that we are moving along, because that will allow us to have it move the way essentially that we need. So what we can do vector3 dot project on plane. We give it the vector, and the ground check result has a normal in it. That gives us a new movement vector. And this is where, if we needed to do slope limits, we actually could. So we could set up here public float slope limit. And if I configured that to say 60, then I can check that slope limit here and say, okay, well, if movement vector dot y, so if we're moving up, so we always allow moving down a slope. So moving down a slope is fine, moving up a slope is the only time we do this check. So if we're moving up, and we can check that that's above a very small value, but greater than 0 is generally going to be sufficient. So if it's greater than 0 and we get the angle between vector 3 up and the hit result normal. So our ground check result dot normal. So that gives us the angle, and that gives us the angle in degrees, because we can then check, well, is that greater than config max our slope limit? If it is, then what we do is movement vector goes to 0. Going to move up to steep a slope. So that's good. We've got movement up a slope now, in theory. We want to then actually apply the movement. So the way we generally will apply the movement, I'll actually remove the delta time because the way we apply the movement is pretty easy at this point. Link rigid body, velocity, movement vector. Update the velocity. So I generally find velocity movement feels the best. It gives you the most responsive sort of movement. I generally would recommend using velocity-based movement. So let's test this out. I should be able to look around and I should be able to move around, importantly. So I can look and I can move. I can strafe. Now this slope here, I should be able to move up it, which I can. I should be able to move up some of these other ones as well. Now I am sinking a little bit, so there'll be some other changes we need to make. But I can't move up the really steep slopes, so that's good. So we can check and see what's likely happening there is because we're moving by velocity, notice I am up in the air. So we generally, when we're doing the velocity movement, we need stuff to pull us back to the ground a little bit. That's not uncommon, that we want to have stuff bringing a bit of force there, bringing us back to the ground. Likely what we would find if I set up a debug log not grounded, likely what we would find is we've got a lot of things indicating that we're not actually grounded at this point. So if we test with that, and we'll turn collapse on because we'd expect quite a few. So it's currently thinking we are not grounded. So that's something where we want to go and check with the setup here, make sure what's happening is correct, that it's actually picking up the right stuff. Very easy to have bits that it's missing with that. So it should be doing its cast. You can see the start position looks correct. The ground check distance looks correct as well. Because our linked rigid body's position is 0.9. It's probably a little bit larger than we need to be checking. So the sphere cast is currently failing to actually hit anything. So we saw that our check here was failing. And if we take a look and add in just an empty object, you can see the center of our player is actually in the middle of the character, not at the ground, not at their feet there, which that's actually not ideal. That's not really what we want. So what I want to do is I'm going to drop Y to 0. We're going to update our collider. So it goes up to 0.9. We can fix up the radius at the same point. And then we need to move the camera as well. So now if we take a look, that looks better. So that's just something we need to watch for. With that, the ground check buffer, I'm also going to reduce that to 0.1, so make it a lot smaller. That'll mean updating the data file for it, but that's okay, because we can actually just reset those and turn off a couple of the ones that we needed to. So we're going to check then again with that. And what we're expecting to see now is, because we are starting, because what was happening before was we were essentially starting from the player's head and going only to the middle of the player, which is obviously not correct. So we'll run this now. So it runs, and now it's correctly recognizing that it is actually there. And then we move along these, and you'll notice I don't go floating. And the reason for that is because my movement vector before, it wasn't thinking I was grounded, so it was actually projecting that movement out. So we would have needed to, in that case, add a little bit of force. It actually is going to be a thing where when it's not grounded, we will actually add on a little bit of force to the character. Because otherwise what happens is we very slowly fall down like that, which is not what we want. And that's because we're constantly controlling the player's velocity there. So we do need to do a little bit more management for the jumping side of things. But the main thing is right now we have got a Rigidbody based controller. We can look around, we can invert our controls. I can move. If I hold down Shift, I can be running. So if I move, then it's hard to see if there is much of a difference happening. So that's something where what I would do is with the running, update the actual state of this. So output an indication of whether or not it actually is running. So we can do that here. A debug log is running because we want to make sure that the is running is working correctly. The other thing we want to do there is if our movement input has kind of gone to 0, we can probably take off the running setting as well. That would be something, I won't automatically do that because I think that is something where it's a useful thing to give ourselves control over that. So I won't automatically do that at this stage. But I do want to check and make sure that running is actually properly getting set. So at the moment, it should be correctly false, which is right. That's what we expect. I tap Shift, it's staying true. I tap Shift again, and it's gone back to, now it seems to be flickering between them. And so there's obviously a bit of an issue there with that. So that's something where we want to go and check and see what's happening with our running. So we've received the input, but the input is just coming through as true. So we saw that it was, the running was not triggering correctly. So we need to, if we go to the run, because we're not getting any release events, which makes sense, because we haven't told it that we want to know when there's a release. So we can go to press and we can tell it that we want to know when it's been released only. We can also tell it we want to know press and release. So that's going to mean that Boolean will get updated whenever it gets activated, which is good. We can also then make a little bit of a change in terms of how we work with this, where if the input is run and we are not currently running, then we set it to true. And the criteria for stopping running is actually down to our movement input. So if movement vector magnitude is less than float epsilon, so essentially less than a really small value, then is running is false. And actually we can do this tied to our movement input. So we would do this right up the top here. So if there's no input, so if the user stops writing input, we stop actually running. So now we want to make sure that this behavior works for the toggle side of things. So it's correctly saying false. I tap it. It's correctly saying true. I ran over the edge. So it's going to force me to stop. Definitely need some fences in there. Or better movement coordination. So I'm running. I can tap it again and it won't do anything. But as soon as I stop input, it goes back. If I hold it, it's fine. So the input there is working well. If I switch this so that it is not using run as a toggle, and just make sure that that is definitely working, then I hold it down, I'm running, I let go, and I'm no longer running. So we've got the initial parts of our first-person controller going. We have camera movement. That's camera set up as a Cinemachine one, so we can easily do different effects and blends there. We have it a Rigidbody based controller, so we'll be able to apply physics to it. We're using the new input system. So we've got camera movement, we've got character movement, we can move up and down slopes, and we have a slope limit in, and we know whether we are grounded or not. So what we're going to be doing next time is starting to handle more of those cases, like things like stairs, handling when we are being able to jump and falling, because those tie into each other fairly closely. So stairs and jumping and falling, we'll start to look into those next time and get those parts of it up and running. Thanks, folks. I hope you found the video helpful. If you have found it helpful, chuck in a like and subscribe. Really helps out. It's really appreciated. If you're looking for the code for the project, that is available up on GitHub, and there's a link to that in the description below. If you've got any comments, chuck those in below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below as well. But until next time, bye.